If you remember from the periodic table video, we talked about that in our periodic table, we get metals to the left and non-metals to the right. Now, bonding is divided into three: ionic, covalent, and metallic. Why do elements bond or atoms bond? They bond to gain full outer shell or noble gas electronic configuration. And they do so by three ways: either by transfer of electron between a metal and a non-metal. So that is ionic bonding, which is between metals and non-metals. Covalent bonding is the sharing of the electron between two nonmetals, and metallic bonding is between the metals, where there's an electrostatic force of attraction between fixed positive ions and delocalized electron. So if any formula is given to you, you can easily say whether it is an ionic and covalent bonding, seeing what atoms are bonded. So if in carbon dioxide there's carbon and oxygen, which are found to the right side of the periodic table, they are two nonmetals, so that is covalent. Ammonia is nitrogen and hydrogen, which are again two nonmetals, so that is covalent. Nitrogen is nitrogen, which is covalent. Water is covalent. Sodium chloride is sodium, which is to the left side, and chlorine, which is to the right side. So this is ionic. Calcium fluoride is ionic. So just by looking at the formula, you can also say whether it's ionic, covalent, or metallic bonding. Now, what is ionic bonding? Ionic bonding is between a metal and a non-metal, and you should understand how you draw the dot and cross diagram. So in dot and cross diagram, you do three things. First of all, write the elements and write their electronic configuration and write their outer, just draw their outer electron. So aluminium is 283, fluorine is 27. So in aluminium, I've drawn 3 electrons with a dot or a cross, or the other one with a dot or a cross, and then I'll choose 7 electrons. Now, aluminium has to get rid of 3. So 1 electron from an aluminium goes to fluorine because fluorine just needs 1. But that makes aluminium to lose 2 more. So it takes the help of 2 other fluorine. So you'll draw the outer electron, show the arrow. So first write the symbol, write the electronic configuration, show the outer electron, show the transfer. And then write the charges. As aluminium has lost 3 electrons, it has got 3 plus charge, and fluorine has got 1 minus charge, but there are 3 fluorines. And this is how you need to draw the dot and cross. Remember, write the electronic configuration, show the outer electrons, and show the transfer. Okay, now whatever we have drawn, we'll write that in a definition. So ionic bonding is between a metal and a non-metal. The metal is losing an electron to a non-metal, and as metal is losing an electron, it is getting a positive charge. Non-metal gains an electron and becomes a negative charge, and there's an electrostatic force of attraction between an opposite charge ion, resulting in ionic bonding. So metal loses an electron and becomes positively charged. Non-metal gains an electron, becomes negative charge, and there's a strong electrostatic force of attraction between opposite charge ion, resulting in ionic bonding. So I hope this dot and cross diagram is clear to you. Now let us take another example of magnesium and chloride, magnesium chloride. So I'll write the first electronic configuration. Magnesium is 282, chlorine is 287. Then I'll draw the outer electron. For the outer electron, my magnesium, I'll show 2 electrons, and chlorine, I'll show 7 electrons. So that's my next diagram. Magnesium, I'll show 1, 2 electrons. Chlorine, I'll show 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. Magnesium will be losing 1 electron to chlorine. Magnesium has to get rid of 1 more, so it will take another help of the chlorine. And then what will happen at the end, magnesium has lost 2 electrons, will have a +2 charge. Chlorine has 7 electrons, 1, 2, 3, 4, 5, 6, 7, and a dot with a -1 charge, and there are 2 chlorines. So ionic bonding is between metal and non-metal. Metal loses an electron, remember, and becomes positively charged. Non-metal gains an electron and becomes negatively charged. There's a strong electrostatic force of attraction between opposite charge ions, resulting in ionic bonding. Next is, you should know what are the properties of the ionic compound. They are brittle solid with definite crystal shape. They are good insulators in solid forms but becomes good conductors. This is very important in liquid or dissolved form. High melting and a boiling point compared to the molecular bonds. Now the reason for these property you should know. So in ionic compounds, there's a strong electrostatic force of attraction between an opposite ions. This results in the formation of giant ionic lattice. Now, why it is a conductor in a liquid form? In solid form, the ions are not free to move as they are held together by strong electrostatic force of attraction. In molten or when they are dissolved in water, the ions are free to move and conduct electricity. And why they have a high melting and a boiling point? Again, because there's a strong electrostatic force of attraction between opposite charged ions. It forms a giant ionic lattice. So large amount of energy is required to overcome these strong electrostatic force of attraction. Therefore, they have a high melting or a boiling point. Okay, so this is how you explain the properties of ionic compounds. However, if I asked you to compare whether aluminium chloride, magnesium chloride, or sodium chloride, which one will have a greater melting point, it depends on charge. Greater the charge, strong will be the electrostatic force of attraction. And remember, aluminium forms 3 plus, magnesium forms 2 plus, sodium forms plus 1. So since aluminium has a greater charge, it will have a stronger ionic lattice. So aluminium chloride will be more stronger as compared to magnesium chloride as compared to sodium chloride. Okay, so I hope this is clear to you. Now next is how to write the ionic formulas. To write the ionic formulas, the step is you write the symbol, write the charges. Up to group 4, the charge is same as the group number. After group 4, it is group number, take away 8 and then do crisscross. For example, if I gave calcium and calcium oxide. Now, write the symbol, so that is Ca. Oxygen, calcium is in group 2, so charge is 2 plus. Oxygen is in group 6, so 6 minus 8 gives a 2 minus charge. Since both charges are same, they get cancelled, so the formula of calcium oxide is CaO. Sodium oxide, sodium is in group 1, has a plus 1 charge. Oxygen is 6, 6 minus 8 is 2 minus, then you crisscross, 2 of oxygen comes underneath sodium and 1 of sodium come underneath oxygen. Remember, it's the numbers that get crisscrossed. Generally, we do not write 1, so the formula would be Na2O. Then work out magnesium nitride. Magnesium is group 2, so that is 2 plus. Nitrogen is group 5. 5 take away 8 is minus 3. And then you do crisscross. 3 of nitrogen comes underneath magnesium. 2 of magnesium come underneath nitrogen. So this is Mg3N2. Okay, so please try all of them and then you should get sodium sulfide to be Na2S, sodium chloride to be NaCl, magnesium chloride to be MgCl2 and aluminium chloride to be AlCl3. Okay, now these are all the symbols that you can get from your periodic table. However, there are some complex ions which you do not get from the periodic table. You need to remember their charges. I have tabulated this for you here. Make sure you remember them. If you're finding hard to remember, put it on your study room, see it every day, and you will memorize them. Ammonium is NH4 plus, hydroxide is OH minus, carbonate is CO3 2 minus, sulfate is SO4 2 minus, nitrate is NO3 minus, phosphate is PO4 3 minus. Now magnesium hydroxide, you know Mg is group 2, so that is 2 plus. Hydroxide is OH from minus 1, you crisscross. Remember, in the complex ion, you have to draw the bracket because it's the OH that gets 2. So the formula would be MgOH2. What is the formula of aluminium sulfate? Aluminium is 3 plus, SO4 is 2 minus. We do the crisscross. Aluminium will get the 2 of sulfate, so it will be Al2. The whole sulfate gets a 3 number. So you put SO4 entire in a bracket and you write 3. Okay, so in this way you can get calcium phosphate as Ca3 PO42. Magnesium nitrate is MgNO3, which is 2. Calcium carbonate is CaCO3 and sodium phosphate is Na3PO4. So I hope how to work out the formulas of ionic compounds with complex ions is clear to you. And ionic bonding. Now let's move on to covalent bonding. It is between two nonmetal. It shows the sharing of electron. More than one electron pair gets shared, it will become double or the triple bond. Now what you do is you draw the circle, Draw the outer electrons, one with the dot, one with the cross, and see how much electrons both needs to gain full outer shell and share that in the middle. For example, hydrogen has one, needs one more, so you put one electron at the center. Chlorine also needs one, so you put one chlorine electron at the center and draw the rest on the rings. Chlorine each need one, so you draw one electron of each at the center and make the rest. Water, between an oxygen and hydrogen, there's a sharing of one electron each. Nitrogen and hydrogen, between each of these circles, sharing of one electron. Carbon and hydrogen, one electron each. But nitrogen both needs three electrons to complete the full outer shell, so you draw 3 electrons in the center. Similarly, oxygen needs 2 electrons, so you draw 2 at the center. Carbon, oxygen, you draw 2 each at the center. So oxygen is a double bond. Carbon and oxygen is a double bond. Nitrogen and nitrogen is a triple bond. Okay, so I hope these dot and crosses are clear to you. Please make sure you understand them because they are often asked in the exam. Okay, now since we have done covalent compounds, we should know the properties of them. Covalent compounds are classified into simple molecular and giant covalent. Simple molecules are oxygen, chlorine, and methane. They have weak intermolecular forces between them, therefore they have low melting and a boiling point. However, their intermolecular forces increases with size, so therefore polymers which have covalent bonding between them, high melting and a boiling point due to their chain length. Whereas diamond, graphite, and silicon dioxide are the examples which have a giant covalent structure, therefore they have strong melting and a boiling point. Now, ionic compound, let's compare the difference between ionic and the covalent compound. Ionic compounds are crystal, covalent are solid, liquids, and gases. Ionics have high melting and a boiling point, covalent have lower melting and a boiling point. Ionics are hard and brittle, covalents are poor conductors. Ionic usually are soluble in water, covalent are not. Ionic undergo electrolysis and covalent are flammable. Okay, so now let us see the giant covalent structure, diamond and graphite. This is the difference between them. Diamond has a hard, rigid structure, whereas graphite has a layered structures. So diamond is hard, has a high density. Graphite is soft and greasy, lower density. In graphite, 3 electrons are bonded to form a ring and 1 electron is localized for each carbon. These delocalized electron make it a good conductor. So diamond is an insulator, graphite is a conductor. In diamond, each carbon atom is covalently bonded to 4 other carbon, giving it a strong rigid structure. In a graphite, carbon atoms are bonded in the form of layer, in the form of hexagon. No covalent bonding between the layers, so they can easily slide past each other. And each carbon is bonded with 3 other carbon, leaving the 4 electron delocalized. So diamond has no delocalized electrons used in cutting or in jewelry. Graphite has delocalized electrons. It is used in pencil lids. Okay, so I hope the structure of diamond and graphite is clear to you. Now they can ask you this question: why graphite is tough and slippery, or why graphite conduct electricity. So in graphite, carbon atoms are bonded in the form of layers, in the form of hexagon. No covalent bondings are between the layers, so they slide past each other. The layer have only weak intermolecular forces between them. So by applying a little pressure between the layers, they can slide past each other, making graphite soft and slippery. On the other hand, in graphite, carbon's atoms are bonded in the form of layer, in the form of hexagon. No covalent bonding is present between the layers, so they slide past each other. Each carbon atom is bonded with 3 other carbon, leaving the 4th electron as delocalized. And these delocalized electrons are mobile electrons which move and conduct electricity. Okay, then there are other 2 allotropes of carbons which are there in your syllabus. It's a fullerene, which is a hollow shaped molecule having hexagonal rings like a buckyball, also known as Buckminster fullerene. Carbon can be in the form of pentagon or the hexagon ring, and it is used as catalyst, drug delivery, or treating cancer. Graphene is a layer of interlocking hexagonal ring like a shingle sheet of graphite. It is light, rigid, 100 times stronger than steel, perfect thermal conductor. It is a better conductor than graphite, light and have low density. Therefore, it is used in making copper chips, computer chips, and flexible electronic display. Okay, and then we have carbon nanotubes, which looks like this. They are cylindrical fullerene with the length greater than the diameter. They have a high tensile strength, so they are used in making reinforced composite materials, and they have a high electronic conductivity, therefore used in electronic conductivity. or industries. Now comes the last bonding, which is the metal. It is between two metals. You can see they are fixed positive ions in the sea of delocalized electrons. There are layered structure forming a giant lattice, and there's a strong intermolecular forces, strong electrostatic forces between the opposite charge ions and the delocalized electron, resulting in metallic bonding. You should be able to draw this diagram and explain these points. Fixed positive ion, delocalized electron, as you have a lot of properties on the basis of them. So what are the properties? Metals are malleable. What is the meaning of malleable? They can be hammered into any shape. Metals are ductile, means they can drawn into wires. They are good conductors of electricity, and they have high melting and a boiling point. So why metals are malleable? Because the metals have layered structures. They can slide past each other just by little hammering. Ductile, again, because they have layered structure, they can be hammered. They are good conductors of electricity because there are mobile electrons. There are delocalized electrons which can conduct electricity. And due to strong electrostatic force of attraction between fixed positive ion and delocalized electron, they have high melting and a boiling point. Next is a very important concept of an alloy. You can see this is a pure metal having a layered structure. When you mix it with another metal or a non-metal being different in size, it interlocks these spaces so the metals can no longer slide over each other. Example, steel is the alloy of the iron, which is more strong and resistant to corrosion. So in metals, the particles are arranged in layers. There's a regular arrangement of fixed positive ions which can slide over each other by applying pressure. However, in alloys, there's a mixture of metal with another metal or a non-metal. Another metal being different in shape and size distort the regular arrangement of the metal ion. As a result, the layers can no longer slide past each other, making a metal strong. Next, you have a concept of nanoparticles. These are the particles that are size 1 to 100 nanometer. Now, 1 meter is 10 to the power 9 nanometer. Okay, so 1 nanometer is 1 times 10 to the power minus 9 meters. Now, how do we get to know to this calculation? You need to remember this chart. It's killing metal Milo Mickey nano pictures. Km, milli, micro, nano, picometer, and all of them are 10 to the power 3. So from kilometers to meter, you time by 1000, meters to millimeters times by 1000, and when you go reverse, you divide by 1000. So if you need to convert the nanometer into meter, so you go from here to here, there are 3 bumps, so you divide it by 10 to the power 9. So 1 nanometers is 10 to the power minus 9 meter. For example, convert 10 nanometer to meter. So nanometer to meter is divided by 10 to the power 9. So 10 divided by 10 to the power 9 is 10 to the power minus 8 meter. Convert 10 nanometer to micrometer. So now let's see how you do that. 10 nanometer is here, micrometer is here. They both have divided by 10 nanometer to micrometer. So this is a 10 nanometer, this is millimeter. So if you are converting 10 nanometer to a millimeter, you divide it by 6. So that becomes 10 power minus 5 meters. So I hope this is clear to you. Now, why nanoparticles are important? Because as the size decreases, the air surface area to volume ratio increases. Therefore, nanoparticles being very small size have large surface area to volume ratio, making them very useful in science and medicine. You can see if you have a cube of 1000 meters, its surface area would be 6 times 1000 by 1000, which is 6 times 10 power 6, and volume would be 10 to the power 9. So surface area to volume ratio is 6 times 10 power 3. On the other hand, when you have 100, then the surface area to volume ratio is 6 times 100. So with an decrease in size, surface area to volume ratio increases. Therefore, nanoparticles are very important, being having high surface area to volume ratio. So, as we have seen that the nanoparticles have high surface area to volume ratio, they have a variety of uses. They're used in medicines for drug delivery or to kill cancer and tumor cells. They're used in cosmetics, they're used in sunscreen to block sunlight. They're used in household as self-cleaning window panes. The nanoparticles are coated with materials. When light falls in them, they carry out a reaction and breaks the dirt, and which is washed away by water while raining. And being having large surface area to volume ratio, They are used in small quantities, so they're very effective as a catalyst. However, there are a lot of risks of nanoparticles due to small size. They can cause difficulty in breathing. They can accumulate in the environment and cause air pollution. Due to their large surface area, a small spark can result in violent explosion, making them risky to use. They're toxic and cause breathing and respiratory problems. Due to their small size, they can also cause water pollution and risk the aquatic life. Okay, so I hope all these types of bondings with their properties are clear to you. Now, there are 3 states of matter, which is there in your syllabus. I think you must have remembered from your key stages. 3, 4 particles in solids are closer together, have fixed shape, strong forces between the particles, definite volume, cannot be compressed and cannot flow. On the other hand, liquids are slightly closer, do not have fixed shape, there's weak forces between the particles, have fixed volume, can be compressed and can flow. And gases, the particles are far apart, do not have fixed shape, they have weak intermolecular forces, do not have fixed volume, highly compressibles, and can flow. So you can see solid particles are very closer to each other. Liquid, they are little far apart. In gas, they are very far apart. And solid can be converted to a liquid by melting, reverse freezing. Gas can be converted to a liquid by condensation, and liquid can be converted to a gas by evaporation. Okay, now this is the curve that whenever you increase the heat, the solid temperature is heated, and at the melting point, the temperature remains the same until all the solid converts into a liquid. Then when the change of state happens, the material, the temperature increases, then the liquid converts into a gas, and at a boiling point the temperature remains the same until all the liquid converts into a gas, and then at boiling it converts into a vapor. Okay, so I hope all these terms, all this topic is crystal clear to you. Now there's a time for the key terms we have seen in this topic. Okay, so now let us revise what are all the key terms that we did in this topic. So we talked about ions, ionic bonding, dot and cross, covalent bonding, metallic bonding, intermolecular forces, joint covalent molecules, polymers, delocalized electrons, Fullerene, graphenes, alloys, nanoparticles, nanoscience, states of matter, solid, liquids, and gases. Ions are the charged atoms with unequal number of protons and electrons. Ionic bonding is between metal and a nonmetal, which involves transfer of electrons between a metal and a nonmetal. Dot and cross is a diagram that shows transfer of electrons in an ionic bond or sharing of electrons in a covalent bond. Covalent bonding is the bonding between 2 nonmetals, which involves sharing of electron. Metallic bonding is a bonding between fixed positive ions and delocalized electron. Intermolecular forces is the forces between the molecules which determines the melting or boiling point. Giant covalent molecules are the covalently bonding molecules with a giant structure. Polymers is made up of many repeating units. Delocalized electrons are the mobile electrons which are free to move. Fullerenes is an allotrope of carbon which form a cage-like structure like buckyball. Graphene is the allotrope of carbon which is equivalent to single layers of graphite. Alloys are the mixtures of metal with another metal or a non-metal. Nanoparticles are the particles which are the size 1 nanometer to 100 nanometer. Nanoscience is a branch of science that deals with nanoparticle. States of matter are different form of states that a matter can take, solid, liquids, and gases. Solids are the states of matter with fixed shape and volume. Liquids are fixed shape but not fixed volume. Liquids and then states of matter without any fixed shape and fixed volume is the gases. Okay, so I hope this is clear to you. Next is test yourself. So you need to show the name type of bonding in sodium chloride, magnesium, nitrogen, carbon dioxide, water, and ammonia. Draw dot cross diagram to represent sodium chloride, water, and magnesium. Differentiate between diamond and graphite. Why ionic compounds do not conduct electricity in solid. Why alloys are stronger than metals. Why aluminium has strong melting point than sodium, and what are nanoparticles, give its properties and application. Okay, so sodium chloride is ionic, magnesium is metallic, nitrogen is covalent, carbon dioxide is covalent, water is covalent, ammonia is covalent. Dot and cross diagram, sodium chlorine, you will search 281, 287. Transfer of electron from sodium to chlorine, sodium will get +1 and chlorine will get -1. For magnesium, there's a fixed positive ion in the sea of delocalized electron, and charge of magnesium is 2 plus, so you will put 2 plus. Difference between diamond and graphite: it's hard, insulator, high density. Each carbon is covalently bonded to 4 other. No delocalized electron used in cutting or jewelry. Graphite is soft and greasy, conductors, lower density than diamond. Carbon is bonded in the form of flare, in the form of hexagon. It has delocalized electron used in pencil leads. Why ionic compounds do not conduct electricity in solid? Because in solids, the ions are not free to move. Alloys are stronger than metals because the different size atoms, it distort the regular arrangement, so they cannot slide past each other. Aluminium has stronger melting point than sodium because of its greater charge. It has greater charge, greater number of electrons, so greater charge density, so stronger electrostatic force of attraction. Nanoparticles are the particles of size 1 to 100 nanometer. Due to smaller size, they have high surface area to volume ratio, making them useful in medicine, catalyst, cosmetics, and industry. Okay, so I hope this topic is clear to you. The next step, as always, check the specification, do exam style questions on this topic. All these notes along with exam style question can be found on my website. The link is shared in the description box below. If you have any problem, leave a comment below. We'll reply you as soon as possible, or you can come to our website. There's a 24/7 chat support till your exam to answer all your queries. You can ask anytime. Okay, so I hope you like this video. Do not forget to subscribe to our channel, and do like, comment, and share this video. Do not forget to click on the bell icon so that you can get the notification of all the latest and useful videos I make before your exam. And if there's any specific topic you want me to make a video on, then do leave a comment. I'll make sure I'll put that up before your exam. Okay, so I'll see you next in the next video. Till then, happy revising.